2025. NASA's survey team at the Atlas Observatory in Child detected something extraordinary, a faint object moving rapidly across the southern sky. At first, it looked like a comet, but its behavior defied every known pattern. When its trajectory was calculated, astronomers realized this was no ordinary wanderer. It was moving on a hyperbolic path, a clear signature that it had come from beyond our solar system. They named it 3i Atlas, the third interstellar object ever found after Oumuamua and Borisov, a visitor from another star system passing through our neighborhood for the first and last time. From the beginning, 3i Atlas was strange. Its speed was astonishing, over 150,000 miles per hour, far faster than any typical comet. Archival images revealed it had been traveling undetected for weeks, its motion unwavering, its orbit eccentricity greater than 6. That meant it wasn't bound to the sun at all. It was simply passing through a cosmic messenger from the unknown. Early size estimates hinted that its nucleus could be up to 5 kilometers wide, potentially larger than Borisov, and vastly more massive than Oumuamua. If those numbers were right, 3i's Atlas carried more than 30 billion tons of material, the frozen relics of a distant world. As the object approached the inner solar system, its coma brightened dramatically. Gases and dust streamed outward, creating a long, luminous tail. But scientists quickly noticed something odd. The tail didn't behave like other comets. Its glow shifted unpredictably, and the rate of outgassing seemed to break all known models. Some researchers speculated that exotic materials might be evaporating off its surface, compounds never before observed. Others began whispering about magnetic interactions or even alien engineering. For the first time since Oumuamua, both mainstream science and fringe theorists were watching the same object and asking the same uneasy question: what exactly was 3i Atlas? Then, without warning, everything changed. At 1:17 a.m. UTC, data from NASA's Jet Propulsion Laboratory began spiking. Instruments monitoring the comet registered an abrupt surge in energy, a violent anomaly far beyond what solar, wind, or normal comet activity could explain. Within minutes, a single urgent message appeared on internal systems: possible collision event. The signal spread through the global network observatories. Teams in Hawaii, South Africa, and the Canary Islands scrambled to confirm the readings. 4 minutes later, the data stream went dark. Every telemetry source flatlined. For 20 agonizing minutes, 3i's Atlas vanished from NASA's sensors, as if it had been swallowed by the void. Inside the control rooms, tension turned to alarm. Red alert protocols were activated, something reserved only for catastrophic space events. The Planetary Defense Coordination Office was notified, waking its director, Dr. Elena Thorne, in the middle of the night. The message she received was brief and chilling. Unexplained impact, loss of contact. Within an hour, NASA, the European Space Agency, and military space commands were all in emergency session. No one could confirm what had struck the interstellar object or how much debris was now spreading across the solar system. But everyone understood the implications. Collision modeling teams began running thousands of simulations. The results were chaotic. If a small asteroid, even a meter across, had slammed into 3i Atlas at tens of kilometers per second, the energy released would have been enough to shatter it completely, ejecting fragments at enormous speed. Larger impact scenarios were even worse, suggesting total vaporization of parts of the comet in a spreading cloud of high-velocity debris. Some of those fragments, though few in number, could potentially cross Earth's orbit within weeks. The probability was tiny, less than 1 in 10,000, but not zero. And in planetary defense, even the smallest chance carries enormous weight. The situation grew more troubling as analysts uncovered a glaring blind spot. NASA's major survey systems, ATLAS and PAN-STARRS, mainly cover the northern sky. Much of the southern hemisphere, including vast stretches over the oceans and Antarctica, remains unmonitored. If any fragment approached from that direction, humanity might not see it coming until hours before impact. The world had already learned that lesson once. In 2013, when a 20-meter asteroid exploded without warning over Chelyabinsk, Russia, injuring more than 1,000 people. Now, hundreds or even thousands of new fragments could be drifting unseen through space, some large enough to survive atmospheric entry. At 2 a.m. UTC, a secure meeting began between NASA, the White House, and allied agencies. Dr. Thorne briefed them on the situation: contact lost, unexplained energy surge, and unpredictable debris. The object responsible for the impact remained unknown. Military representatives demanded a full threat matrix. Could any fragments strike satellites or defense assets? The debate grew heated as officials weighed whether to alert the United Nations. Some argued for immediate disclosure to the public. Others warned that panic would spread faster than facts. In the end, the decision was made to classify the event temporarily until orbital analysis could confirm the risks. While the world slept, the most advanced computers on Earth modeled thousands of possible futures. Orbital teams tracked faint glimmers in the sky, searching for surviving pieces of the interstellar traveler. NASA redirected resources to the southern observatories, requesting emergency telescope time in Australia and South Africa. Even amateur astronomers were invited to join the effort, uploading raw sky images to help identify new fragments. For the first time, planetary defense became a global citizen effort, professionals and enthusiasts working side by side to safeguard Earth from an invisible threat. Behind the scenes, engineers prepared for the worst. Plans were drawn up to accelerate the launch of Comet Interceptor 2, a rapid response spacecraft capable of intercepting or deflecting debris on short notice. But time was the enemy. For large fragments, humanity might have days to react. For smaller ones, only hours. Across multiple countries, civil protection agencies quietly reviewed evacuation and shelter protocols just in case the simulations turned real. Weeks passed, and still no clear answers emerged. Some signals suggested fragments of Three Eyes Atlas continued their journey out of the solar system, scattering harmlessly into the dark. Others hinted that a few pieces might still be drifting near Earth's orbital path. But without solid data, no one could be certain. And through it all, one question continued to haunt the scientific community. What exactly hit Three Eyes Atlas? Was it an unseen asteroid, a random piece of space debris, or something far stranger? The official reports remain classified, and public statements have been cautious, limited to anomalous event under investigation. What began as a moment of wonder, the discovery of a visitor from another star, has turned into a mystery cloaked in silence. NASA's response showed how far humanity has come in defending its planet, but it also exposed how fragile that defense still is. Gaps in sky coverage, limits in detection, and the unpredictable nature of the cosmos remind us how little control we truly have. The story of Three Eyes Atlas isn't just about an interstellar comet. It's about the boundaries of human knowledge and the thin line separating safety from the unknown. Even now, as telescopes continue to scan the heavens, one truth lingers. Space is vast, ancient, and alive with motion. And somewhere out there, fragments of a shattered visitor from another world may still be drifting silently through the dark. A reminder that the universe always has one more secret left to reveal.